All right. Hi. Hey. Hello. All right. Let's get this done. Oh my. Whoopsies. All right. 752. Last thing we got to talk about solving logarithmic equations. So we're gonna do a couple warm up things, a little review, and then we're gonna learn the last little piece and kind of compare it side by side with what the previous video was. So as a warm up, Dawson invests $500 in an account that pays 7.3% interest per year. How much will he have in his account in 6 years? So investing means you are hopefully growing your money. So we're going to assume this is exponential growth. 7.3% interest. I'm just going to do this right away. 7.3% interest. If I were to move the decimal point twice, would be 0.073. How much will he have in his account in 6 years? So there's our time. So we have A equals P times 1, hopefully plus 0.073 to the 6th power. I don't know why I put P, because we know the initial value is 500. And now we can type it in. So we got 500 times 1 plus 0.073 to the 6th. And that gives us $763.08 if we're rounding, which we should. So there we go, 763.08. Okay, so exponential growth equation where you're given a time and you are just asked to find the future value. Let's revisit real quickly what it means to rewrite a logarithm as an exponent. In the previous video, we rewrote exponents as logarithms. But here, if I have log base 3 of 243 equals 5, remember this is my base number. I'm going to raise it to that power. And that equals that. Okay, so log base 3 of 243 equals 5 is the same as saying 3 to the 5th power equals 243. So there's that first one. And then here, log base 5 of x equals 4 is saying 5 to the 4th power equals x. Okay, so we're not necessarily solving anything. We're just rewriting those logs as exponents. Before we get to the new piece, let's just real quick recap what it means to solve an exponential equation. So I know this is an exponential equation because the variable is in the exponent, okay? Variable, exponent, exponential. Here's the exponential portion of the equation is 4 to the power of 2x minus 1. So to get the exponent out of the power, I need to rewrite this as a log. But before I do that, I need to move this 5 to the other side. I need to isolate this exponential piece right here. So here I have 4 to the power of 2x minus 1 equals 22. And now I can rewrite this as a logarithm. Okay, so I'll have log base 2, log base 4 of 22 equals 2x minus 1. And then to type log base 4 of 22, in most calculators, you have to do log of 22 divided by log of 4 because there's no dedicated log button. My calculator does have a log, like base 4 button, but I'm not going to show you that because I want to make sure you can do this with any calculator. So it's 2.229, but with that 7, that's going to round up to 2.23. So this equals 2x minus 1, which means 2.23 is equal to 2x minus 1. Now our algebra takes over, add 1, so 3.23 equals 2x. Divide both sides by 2. 3.23 divided by 2 is 1.615. 1.615 equals my variable x. Okay, so that was a just a quick problem like yesterday. I know it looks like a lot of work, but I kind of wrote it out longer than, just want to make sure I show all the steps that we're doing there. So yeah, that was the first video, 751. Exponential equation, write as a logarithm to solve. Today, we're going to do the exact opposite. If you have a logarithm that has x in the argument right here, right, log of x minus 5 equals 3, I'm going to actually write this as an exponential equation, and that will allow me to solve this. So the first thing I need to do is make sure that my logarithm has a base, and this one does have a base, but remember, if it's not written, it's base 10. So now I'm going to rewrite this expression as a exponent, which would be 10 to the third power equals my argument of x minus 5. So the only thing that should be on the right side of that equation is whatever's in parentheses with the log. Okay, whatever's here is the only thing that should be on the right-hand side when you rewrite this. Well, 10 to the third power is something that I can simplify by typing in the calculator. 10 to the third is 1,000. And then I can simply solve for x by just adding 5, so that'll be 1,005. And we're done. So 1,005, if I were to check my work, log of 1,005 minus 5, sure enough, is equal to 3. Now, in the previous video in 751, we had a lot of decimals, and we had to make sure we rounded to 3. What you're going to find is that with logarithms, much more frequently, you'll have whole numbers, which is nice because then we won't have as many decimals to deal with. So 1,005 is our solution for that one. Okay. Same idea, another log equation, but now the base is given to us. The base is 4. So I'm going to go 4 raised to that power is equal to my argument of 2x plus 1. So 4 to the second power is 16 equals 2x plus 1. Now we just let algebra take over. 15 equals 2x. Cut both sides in half, and I get 7.5. So that is my solution for that equation. Okay, so if you have a log and x is in the argument, you will always just rewrite it as an exponent, and that will allow you to plug some things in the calculator and solve. Oops. Okay. So what happens here if there's more stuff going on than just the logarithm? So here's my log portion. And I'm going to stop highlighting the moment that right-hand parentheses is done, because that's the log portion of this equation. I need to get that by itself before I'm ready to rewrite this as an exponent. So I'm going to get rid of the 4 and the minus 5 like I normally would in any other algebraic problem. So I'm going to add 5 to both sides first. And then that will give me 4 times log base 5 of 2x minus 7 equals 8. Okay, so I just add 5 to both sides. Now I'm going to divide both sides. Whoa. I'm going to divide both sides by 4. So there's a little pre-work we got to do to get the logarithm by itself. Okay, but now that the log base 5 of 2x minus 7 is by itself, notice that the log base will never change. Okay, no matter what algebra you do, that base 5 number is going to stay base 5 until you're ready to rewrite it as an exponent. So here I have 5 raised to the second power. That is 25. And now I'm just going to add 7 and divide by 2. Add 7 is 32. Half of 32 is 16. And we're good. Okay. So let's get this. So a couple more steps. Oh, good Lord. This is my last. Okay, moving on. There's the problem. Go ahead, pause the video, give this one a shot, and we'll wrap this chapter up. All right, so I'm going to add 5 to both sides. 2 times log base 3 of x plus 2. 6. Half of that is 3. So I got log base 3 of x plus 2 equals 3. Now I rewrite that as an exponent, 3 to the third, which is 27. And now to isolate x, I'm going to subtract 2 from both sides. My solution is 25. Okay. Again, I know I'm moving through this quickly, but with the ability to pause and rewind, I want to keep this short. So, kind of a summary of the last two videos. Exponential equation, how to solve, versus a logarithmic equation, how to solve. Okay. If you see the variable you're trying to solve, x, is in the exponent, you will write as a log. Okay. This is yesterday's summary. Rewrite as a logarithm. So I'm going to go log base 5 of 85 equals x plus 1. And now I'm going to, just for the sake of writing myself some steps, I'm going to type this in the calculator. This is also going to act as our summary for the video. I know there's another slide that says summary, but we're going to do this. So log 85 divided by log of 5 is 2.760. So 2.760 equals x plus 1. And I subtract 1 and I get 1.760. Okay. So if you see x in the exponent, use logarithms to solve. Okay. The opposite is if you see x in the logarithm, we're going to use exponents to solve. Just like we did with squares and square roots or multiplication and division. We're using opposite operations essentially to solve these equations. So here, x is in the argument. So we're going to rewrite as exponents. So I have 3 raised to the 4th power equals x minus 5. 3 to the 4th is 81. I add 5 to both sides, and I get my solution of 86. Okay. So as far as this chapter is concerned, okay, this is kind of the ultimate goal. This is what we were building to. That exponential growth, the videos in 7.3 about the definition of a logarithm, all of it is to be able to do this, to solve an equation that has x in the exponent or x in the logarithm. We can solve for the variable now using the inverse operations because exponents and logarithms are so tightly knit. Okay. So that's going to act as our summary. Congratulations. End of chapter 7. Go outside unless it's raining. Then don't. Do whatever you want.